Graphing lines in the form of y equals mx plus b. Our goal today is to graph linear equations in sloped intercept form. Let's go ahead and take a look at how the values of m and b affect our graphs. Consider the following graphs in the form of y equals mx plus b. This may be hard for you to read, so more specifically, all of these lines are in the form of y equals 2x plus b. Basically what I'm doing is I'm varying the value of b. This black line is y equals 2x minus 3, and what I want you to notice is it actually crosses the y-axis right at negative 3. The blue line, y equals 2x minus 1, crosses the y-axis at negative 1. The red line, y equals 2x plus 1, crosses the y-axis at positive 1. The green line crosses the y-axis at positive 3 with an equation of y equals 2x plus 3. So as you can probably notice, there is something of a pattern going on here. Let's now take a look at what happens to the line as we change the value of m. All of these lines are in the form of y equals mx plus 0. So all of them have a y-intercept of 0, so they all pass through the origin, but I've varied the value of m, which represents the slope. I'd like to take a look at the black, blue, and purple line first. This equation is y equals x, or you could think of it as y equals 1x. The blue line, y equals 2x. As I increase m, as you can see, the line gets steeper. The line gets steeper as it moves from left to right. I always refer to slope from left to right as you read a book, just to keep it consistent. The purple line is y equals 4x. Again, as we increase m, the line gets steeper, moving up from left to right. Now looking at the brown, red, and green line, the green line is y equals negative x, or you could think of it as negative 1x. The red line, y equals negative 2x. Again, it is steeper, but now it's going downhill from left to right. And y equals negative 4x. It's going downhill because it's a negative slope, but it's very steep because of the 4. Let's put all those pieces together. A linear function is given by y equals mx plus b, or f of x equals mx plus b, has a graph that is a straight line with a slope equal to m and crossing the y-axis at 0, b. The point 0b is called the y-intercept. So to summarize, you get two key components from a line in this form. M is equal to the slope, b is equal to the y-intercept. And that is all the information you need to make a nice graph. Let's take a look at a formal definition. Y equals mx plus b is called the sloped intercept equation of a line. Let's go ahead and graph a couple of these. Let's graph y equals negative x plus 3. This is the form the line is in. We need to identify the value of m and the value of b. Now, it's easy to see that b is equal to positive 3. M is the coefficient of the x term, which would be negative 1. In order to use the slope, though, it's helpful to have it in fraction form, so I'll make it negative 1 over 1. In order to graph this line, we need to plot the y-intercept, and then use the slope to find additional points. The slope of negative 1 over positive 1, I would go down 1 unit and right 1 unit. And this would be our line through those 2 points. It's as simple as that. Let's try another. What would our y-intercept be? Our y-intercept is negative 4. Our slope of this line is positive 2/3. We plot the y-intercept, use the slope to find additional points, up 2, right 3. Our line passes through those 2 points. That's how we graph lines in sloped intercept form. We can easily verify these on the graphing calculator. I'll verify the second one. From the main screen, we hit y equals, the top left. enter in our equation. However, remember, with our slope, especially if it's in fraction form, we need to make sure we include it in a set of parentheses. Times x minus 4. Hit graph. Gives you a nice visual that our line looks accurate, but more specifically, if we hit second graph, we can verify that 0, negative 4 is 1 point on the line, and we can now verify that the point 3, negative 2 is another point on the line. Therefore, we have graphed this correctly.